All right, so 5.1, systems of equations. These aren't bad. We've actually done a little bit of it in the first chapter, except we did it with one variable. Now we're going to increase it to 2 variables. And if you have 2 variables, that usually represents linear, x and y. So when we talk about equations, system of equations, and you're talking about a coordinate system, there are only 3 possible outcomes. Let's talk about all 3. So if you're 2 lines in a coordinate system, what are the 2 outcomes? You could have a line.
Come on.
Yeah.
I know you posted a grade.
I'm getting to it, don't worry. Let's do this first.
Okay.
So, one of the possibilities in the system is you have 1 line. Now, when we're talking about a system of equations, we're talking about 2 or more. So, what is the other possibility for the second line in this first picture?
For it to be parallel.
You could be parallel. Okay. So they would have absolutely no points in common. So this is the parallel setup. The other possibility is you have a given line
And one that crosses it.
and one that crosses it, better known as what word?
Perpendicular.
No, perpendicular crosses
Intersecting.
intersecting. So the 2 lines could actually share a common point. So they would be intersecting. Those are the ones of more interest. What's the third possibility that nobody ever gets? I'll give you a line. So you're either parallel, they share no points in common. You intersect, they only share 1 point in common. Or no points in common, 1 point in common,
All points in common.
all points in common. So if it's all points in common, you're talking about the exact same line. So they're lying right on top of one another. In other words, an infinite number of possible intersections. So this I would describe as infinite, and this one is 1, and this one is none. They share no points in common because they're parallel. So these are the only 3 things that 2 lines in a plane can do. They can be parallel, they can intersect, or they can be the exact same line. Now, parallel and the exact same line are 2 lines that have the exact same slope. So the only thing that distinguishes these 2 systems is this one has different y-intercepts, this one has the exact same y-intercepts. But their slopes are exactly the same. Does that make sense? So you can't just compare slopes to determine if they're parallel. You have to look at their slopes and their y-intercept to determine if there's no answers whatsoever or if every answer is an answer. Infinite number of answers. All right, so this is what a system looks like. Fancy bracy, make it 2-line one, not a single line one, a double line one. And you could possibly have something like 2x minus 3y is equal to 7, and y equals 4x plus 5. And that would be a system. And the system, you're trying to find the value for x and y. Now, are these 2 lines parallel? No. And so we're not getting no answers and we're not getting infinite answers. We should only end up with 1 answer, that with the point of intersection. All right. Second thing, how am I going to find x and y so that they have a common point? There's a couple methods that we can go through. You've done it once for the extra credit project if you did it, but I don't like doing it that way. It's a more difficult way. So one method is called substitution. And the nice thing about substitution, it always works.
Yeah, and it's the hardest too.
And it's the hardest. But it works for any system. It doesn't necessarily have to be linear, and I'll show you that later. So substitution basically is solve one equation for either variable. So you either can solve for x or you can solve for y, and it doesn't have to be the top equation, it could be the second equation. So it's your choice. So the choice you should make is find the one that's easiest to solve for. This one I set up nicely. 2, plug this into other equation. Don't plug it into the same one because then you get the infinite number of answers. It's the same line because you plug one line into the same line. Your answer is going to be 0 equals 0 and it's not going to get you anywhere. Alright, so this one I pretty much already set up. If you're looking at these two equations, which variable would you solve for? Y, it's already solved for. Here y is all by itself. So step number 1 is already taken care of. So all you have to do is take this y and substitute it into the other equation, the other y. So when you do that, you write 2x minus 3 something is equal to 7. The biggest mistake that people make is they concentrate on what they're plugging in and forget that the form is actually more important. What goes inside the parentheses?
4x plus 5.
4x plus 5. And then solve. So basically what we've done is we've actually done this before with maximizing those fences and whatnot. Solve one equation, shove it into the other one. Same idea, substitution. So we took a 2-variable equation and made it a single variable equation. All right, simplify. So we get 2x minus 12x minus 15, right? So what's 2x minus 12x?
-10.
So you get negative 10x. And then minus 15 is equal to 7. Now, since I made this up off the top of my head, the answer is probably going to be absolutely horrible. How do I solve for x?
-10.
So you get negative 10x is equal to, what's that, 25?
2.
Huh?
22.
22. And then x is equal to, after dividing by negative 10?
Oh, it's going to be a negative 11 fifths.
Negative 11 fifths. So we have solved for one of the coordinates. So basically all we have found is the x coordinate over here is negative 11 fifths. So what else do you have to find?
Y.
The y coordinate, so you know how high it is,
Mhm.
or low. This is just a generalized picture. So how do I find y?
Substitute 2x minus 3y.
Do you want to do it into the 2x minus 3y?
No.
I wouldn't. I'd substitute it into the one that has y all by
So
itself. So if I substitute into that y,
that's what I'm saying. Substitute instead of 4.
Hmm?
I'm talking about the first part instead of 4. Instead of y equals 4x. That's what I'm talking about. Substitute it in there.
substitute the negative 11 fifths into the second.
Oh, that number. Oh, okay, got it.
Yeah, no, I don't want you to flip-flop it and
Gotcha.
substitute backwards.
Mhm.
All right, so if I plug it into this equation, I'll come down here. You're going to get y is equal to 4 times negative 11 fifths plus 5. Ugh, fractions. Horrible. This is y is equal to negative 44 fifths plus, what would you write 5 as? Without a calculator. To get a common denominator.
4/5. I mean 5/5.
25 over 5? 25 over 5. Because it has to equal 5. Alright, so negative 44 plus 25.
Negative 19.
Negative 19.
Mhm.
So this would be negative 19. So, for a final answer, you can't leave it like that. Because this thing is a coordinate on a piece of graph paper, you have to take your answer and write it as x first. Negative 11/5, comma, y second. And this is the coordinate where those two lines intersect. It's just the coordinate of the two lines intersection. And that's it. That's the substitution method. Pretty easy, right?
Mm-hmm.
It's not the best method, but it is one that works for any situation. For instance, what about this system? Now I gotta look at my notes.
Smile.
No. Are there gonna be short videos?
Yeah, there's short videos on this. X squared plus y squared is equal to 25. Y equals 2x plus 4. This is a system. Is it linear? Heck no. So what does the top graph look like?
Parabola.
Nope. X squared plus y squared equals 25. You can't graph that. No one remembers? X squared plus y squared equals 25. What is it?
It goes up on. No, it's like this.
Oh, it's a triangle.
Triangle?
Oh.
I couldn't even graph a function. Well, it's not even a function. I'll give you that in a second. It's not a function.
Mm-hmm.
You've seen it before. Looks like Pythagorean theorem, so that's where you're getting the
Yeah.
triangle from. I understand that now. Circle? X minus h all squared plus y minus k all squared equals r squared.
Mm-hmm.
You don't remember that?
Mm-hmm.
Oh, you know it's going to
That's
show
for
up
the
in the
extra
test.
credit video.
Yeah, it's that extra credit stuff. So what's the center?
That I think answer.
Oh, do you see an h or a k up there?
Yeah.
So what's the center?
0.
0. So the center is the origin. What's the radius? 5. So it goes right, left, right 5, up 5, left 5, down 5. You get a nice little circle. Yay! So the top equation is a circle. Bottom equation,
It's a line.
it's a line. Slope,
2.
y-intercept,
4.
4. So the y-intercept is here. Slope of 2 means it goes up 2 and over 1, so it's probably looking something like this. So how many times does this graph intersect the circle?
3.
The red line running into the blue circle.
2.
2. It only runs into it here and here. So these are the 2 points that we're interested in. We're trying to solve this system of equation, and it only intersects in those 2 points. Lines and circles only have 3 options also. The line doesn't touch the circle. The line touches the circle exactly once. It's also known as a tangent. And the line hits the circle twice. It's the only 3 options. All right, so how do I solve this system? Well, I only have one method so far. Substitution. So substitution says take one of the equations, solve for y. Now, or x. Do you want to solve for y or x in the first equation? Why not? Yeah, it's your squares, so if you solve for one of them, you'll end up with square roots, and not only that, you'd end up with plus or minus square roots, so it's kind of messy. Nicely enough, I left this one as y equals, so you take this one and shove it inside of that one. So you take this y value, and you shove it into that y value. Alright, so when I do that, I'm going to get x squared plus something squared is equal to 25. The something is
2x+4.
2x plus 4. And just start expanding out. So this becomes x squared plus, what's 2x plus 4 all squared?
4x squared.
Plus 8. X.
And another,
Plus 16 is.
yeah, they'll have two 8x, so this would be 16x
Plus 16.
plus 16 is equal to,
25.
alright, how would you solve that equation? Oh, let me pause.
You combine all my terms.
Are you gonna write?
Minus 16.
So this becomes 5x squared plus 16x plus 16 is equal to 25. Then what?
Minus 16.
I'm not sure if I'd want to subtract 16. What kind of equation is
Minus
this?
25.
It's quadratic. You want to get it equal to
0.
0. So if I subtract the 25 this direction, we're going to get 5x squared plus 16x minus 9 is equal to 0. Alright, ways to solve this. First method you should try, factoring. 5 times 9.
Negative 45.
Factors of 45 is subtracted to 16.
9 is 6. That ain't right.
Isn't 3 one of them?
45? Yeah, it's 3 times 15.
3.
It's not going
There's
to work.
not one.
There's not one. So what's the other option?
Quadratic.
Quadratic
Squared.
Boom.
formula. Alright. So that's
What's
negative-
another one then?
well, this is a quadratic equation. I've had people call the quadratic formula the quadratic equation and vice versa. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So b,
Negative 16.
16, so 16 here, 16 there. A, and C is negative 9. And A again is 5. Alright, and then you type it into your calculators and magically come up with an answer.
436.
I was going to do the whole thing, but sure. 16 squared minus 4 times 5 times negative 9 is 436. So this becomes negative 16 plus or minus the square root of 436 all over 10.
Yes.
And then I'm just going to do the rest of the work in the calculator. So negative 16 minus the square root of 436. Take that ugly answer, which is negative 36.9, and divide by 10.
Why
So
wouldn't you divide by 2?
2.
No.
Oh, because it's usually 2 times 1, isn't it? Yeah, but it's 10 in this case. So one of the answers for x, this is x, right? Yeah, x. One of the answers for x is negative 3.7, if you round to the nearest tenth. If I do the plus part of the square root and divide by 10, the other answer is 0.5, 0.488. So it's really close to 0.5. Yay! I found x, which is awesome, except for one problem.
With 2 ounces.
It's only told me that this x coordinate here is negative 3.7, and the one over here is 0.5. That's all it's told me. But I want coordinates, so how am I going to find coordinates?
You put that into the first one.
You pick the two answers and you plug it into which equation?
The first one.
You want to plug it into
No,
x
the
squared?
second.
You can, I
The
mean,
second one.
the first one will give you the answers, but the second one is much easier to work with. So if you plug into y equals 2x plus 4, life is nice. So y equals 2 times negative 3.7 plus 4, and y equals 2 times 0.5 plus 4. It's a negative. So, what's the first answer?
Negative 3.4.
Negative 3.4. Second answer? 5. That makes sense because this is 2 times a half. So that's 5. So for my final answer, the two coordinates that are run into by this line are going to be, this one would be negative 3.7 comma negative 3.4. And it makes sense because it's in the third quadrant and both coordinates are negative. And the other point way up here is going to be 0.5 comma 5. Approximately. Now remember, these are approximations because we rounded those decimals. So that's substitution, linear format, and any other format. You can always find the intersection, well, I won't say it that way. You can usually find the intersection of two graphs in this method. And substitution is the only one that works for this second case. Alright, but substitution can get messy, easy to make mistakes. Maybe if you chose to solve for the wrong variable, you made your work 10 times harder than it actually is. So I'd like to come up with another method that actually works better for the linear case.
Is it the box one? Is it the box one?
Unless it's something I've never called a box before. It's called elimination or subtraction.
This one's easy.
It is, but why it works is a little strange.
Yeah, a little strange.
So I'm going to go about it really strange, and you're not going to like this. But I like showing people why things work. So let's say we have a system of equations. Our blue function, or on the video is going to be a different color. And this other graph. Let's make it go this way. And of course they share this common point. So if I told you that this line had a slope of m1, so the first graph has a slope of m1, and the second graph has a slope of m2. And the common point that they run into each other is x1 comma y1. It's the common point that they run into each other. What is the equation of the first graph with m1 slope?
Oh, I hate this.
What, writing the equation of a line?
No, I hate them M's.
m1 and m2. M is just slope, some kind of fraction.
I don't know.
In this case, they're both positive. So what's the equation of the first line? Did you forget how to write the equation of a line already?
Why wasn't it supposed to be?
The other one, because we're trying to write the equation of a line, not graph the equation of a line.
Are you asking for like point slope?
Mhm.
Oh, y equals,
Nope.
no, y1,
Y,
2.
Y,
Y sub 1,
Y what, Y sub 1?
Y minus,
Y
sub
minus Y sub 1
X.
equals,
Equals m.
X.
and M in this case is
Oh, yeah, down
M1,
parentheses.
X minus
X sub 1.
X sub 1. Refreshing the memory. I like doing this every once in a while because I know the final's coming up. The second line, what would its equation be? Well, it would be Y minus,
Y sub 2.
there's no Y sub 2 in my picture.
X.
No, they're both going through the point x1, y1. Well, x1, y1 is only in this first equation because it's the only point that the blue line goes through that I know. So I mix the point x1, y1 and the slope m1 to come up with this equation. The red one has a slope of m2, but what point does it go through?
Same.
The same one. So it's going to be y minus y1 equals m2 x minus x1. They're going through the exact same point.
I hate this chapter.
Why? This is easy.
Because when you get all them lines on the graph, you gotta tell what's M and what's M1, M2.
No, it's not gonna get that complex.
Okay.
It's not gonna get that complex.
Okay.
I'm only using this to emphasize a point.
Okay.
And that point is this. If I take these two equations and I add them together side by side to side, what do you get? Well, what's y plus y?
2y.
2y. What's negative y1 minus negative y1?
Negative 2y, 1.
Negative 2y1 equals, over on this side,
M1 plus M2.
Are you gonna go ahead
well, we
and
gotta be,
do it then?
we could distribute it out, but I want you to think about it a little bit simpler. Remember back when I keep asking you to do what's ax plus bx?
Mm-hmm.
What is the answer?
ABX.
No.
A exponent to C is A plus B.
Yeah, you can kick the x out, factor it out, and left behind is a plus b. What can I kick out of these two that is exactly the same? So if I kick out x minus x1, what's left behind?
M plus 1 plus M2.
M1 plus M2. I ran
That's
out
what
of
I'm
room.
getting at. You talking about?
I know, I just want to make sure they saw that too.
Is it pretty? No.
So here's what I can do. I don't like these 2's here. So what can I do to both sides?
Minus
Divide by 2.
um,
So when I do that, I get y minus y sub 1 is equal to m1 plus m2 over 2 times x minus x1. What is that? Well, it's a line that has a different slope. It's the average of the slopes, if you want to think of it that way. But what's the only thing that's exactly the same as the original 2 lines? The y1 and the...
it's
This line is still going through the intersection of those 2 lines. So if I take 2 equations and I add them together, they still go through the exact same point of intersection. You're not changing the x1 and the y1, you're only changing the slope of the line. So you have the slope of the line and it becomes fixed through that point when you add them or subtract them together. The only thing that changes is the slope of the line. It still has to go through that point. And because of this technique, we can make life a lot easier for this section and next section. So let me show you what I'm going to do.
19.
System of equations using substitution method. Or I'm sorry, not substitution. Subtraction or elimination method. Now, unlike other systems, this one is best to set up in standard form. Do you remember what standard form is? What is that?
AX plus B. There's an ABC in there.
There's an ABC in there. So for this method, yeah, I said that. There's an ABC in it. AX plus BY is equal to C.
Oh, I had it right.
Where A, B, and C are whole numbers. Or no, I shouldn't say that, integers. They're usually integers. You don't want fractions in there, you really don't want decimals in there, but even with decimals it'll still work out as long as you have X and Y on one side, the number on the other. Alright, so for example, if I have this system, and I want to solve for X and Y. The substitution method says find one of those equations, solve for one of the variables, and plug it into the other equation. So if I was going to do this substitution, would you solve the top equation or the bottom one?
5.
And for which variable, the x or the y?
Not if it's
Solve
Y,
for Y.
the Y by itself.
If you solve for y, it's pretty much all by himself already.
Mhm.
So if I solve for x, I'd end up with fourths and halves, and it just makes things fractions right off the bat. It only makes the work harder, it doesn't give you the wrong answer. But with the elimination method, substitution method, you choose a variable to get rid of. You're going to add these two equations like we did over there in that example, but we're going to choose it in such a way that the variables go away. So you end up with a vertical or a horizontal line, x equals or y equals. So which variable do you want to get rid of? It's a choice.
4, X.
The x's. So if you choose to get rid of the x's, I need to make them the exact same coefficients, opposite sign. So one's positive and the other one is negative. So what could the coefficients of the x's be to,
-2.
what do I need them to be?
Oh.
4.
4. So I'm going to take the top equation, I'm going to call it A. This is for next section. But it makes it a lot easier if you can label them something. I usually use A, B, and C. I've seen people just do I, J, K, or it doesn't really matter. So what am I going to do to equation A and equation B to make the x's go away? I'm going to take the top one and multiply by.
Adam,
I'm going to take the top equation and multiply by. You said it earlier.
-2.
-2. So I'm going to write -2a, and I'm going to add it on to b. So that line there is just what I'm going to do. Underneath it, I'm going to write exactly what I did do. If I take -2 and I multiply the top equation, it becomes -4x plus 6y is equal to
-10.
-10. Where are most mistakes made?
Hold up. Where did you get the 6y from?
-2 times 2x is -4x. You have to do the whole equation. You can't do pieces
then
of
why'd
it.
you just circle the first
Oh,
part?
I just circled those to say these two have to be exactly the same, opposite sign. But once you choose to multiply him by
Okay.
-2,
I get it.
okay. But most people forget to multiply the other side by -2. So they'll write -4x plus 6y equals, and they'll leave the 5. So be careful, you have to multiply all the way
can I tell
across.
you how I got my -2?
How?
To see if it's wrong?
You divided.
Yeah, when I flipped them and made the 4/2 and automatically gave my sign and it broke it down. Would it be wrong or right?
It won't work all the time. It's more like common denominator. It's more like common denominator. All right, so the bottom one, the b, we're only going to put 4x plus y is equal to -2. And we're going to take the two equations and add them all up.
Oh yeah, mine me Adam.
And when you add them, the x's go poof, and they're gone. You get 6y plus 1y, which is
7y.
7y. -10 plus -2 is
-12.
And you get y is equal to
7 plus 7.
-12. And it spits the answer out rather quickly. Unlike substitution, you had to go through a lot of mess to get to it. Now, you have two choices from this point.
Take my Y, plug it into the bottom.
You could plug it into the top or the bottom, it really doesn't matter. But once you plug it in, you're automatically working in
Fraction.
fractions. So personally, I don't like putting in fractions and working with fractions.
Okay.
So what I do, this is just me, you don't have to do it this way. What I do is I start over again and I say, well, I got rid of the x's first, let's turn around and get rid of the y's. And if I do that, all I have to do is come up with the two equations, add them together, and it spits out my y.
The bottom of 3.
So I'm going to multiply b by Three.
Yeah.
3, right? So this one is going to be a plus 3b.
I'm saying it.
And that's just the direction of what I'm going to do, and then I just write it. So a is 2x minus 3y is equal to 5. And b is going to be 3 times itself. So 3 times 4x,
12
12x.
3
3y
equals -6.
equals -6. And then just take these two and
Minus
add them.
bottom.
What happens to the y's?
They go away.
And you're left with
14.
14x is equal to,
1.
and divide by 14, you get x equals
14.
114. And I didn't have to work with fractions at all.
Okay.
So my answer is, in the end, -114, comma,
12, 7 is negative.
-12. Ta-da! Not bad, right?
Mm-hmm.
So that's the elimination method. Now, you do have a choice. When you're done with the first one, you could just take it and plug it into the top equation or the bottom equation. You'll be working in fractions, but it is doable. But me, personally, I like doing it twice. It's just me. I don't like working with fractions. And it also gives you better practice at how to eliminate. All right, so let's do everybody's favorite.
Excuse me, ouch.
You're gonna take this.
No. I quit. You lost.
I knew that would happen.
You lost.
It's not too bad this way though.
And they can disinherit it. And once, what is two? You're right, how I thought.
If I talk and write, I spelled wrong. It's really sad. Tom inherited $1,500 and wants to deposit this into two accounts, one of them earning 9.25 SI. Anybody know what SI is?
Why did you
Simple
do dash?
Simple interest.
Huh?
Simple interest.
Why did you do dash?
I don't know. And the other earned 16.75. I wish we could find a savings account that earned that much. Simple interest. The only reason I'm emphasizing the simple interest is most banks work on compound interest, and that's much more complex. Simple interest is easy. It has a nice little formula. I equals PRT, principal times rate times time. Principal being how much money you put into the account. I only hate word problems because I have to write it down. So,
Should let Joe be right.
after a year, just 1 year, the accounts earned a total of $228.75 in interest, just interest. So I want to know how much was put into each account. How did he separate his money? Did he put $750 in both of them? You know, split it right down the middle. Did he put $500 in one and $1,000 in the other? So it could be any breakup of $1,500. So the way you start this is account A, account B, and totals. Now I'm going to show you the setup of it. I'm not going to show you the solution part. Maybe I should show you the solution. Yeah, I'll show you the solution. All right, so the question becomes, there's two things going on with account A. Account A, number one, you're depositing money. But also account A is earning interest. So you're going to get two different formulas. One of them for a total amount of money, the other one for a total amount of interest. So the first one is just going to be the pure money, P, principal. And the other one is going to be your money.
I thought that was
fine. But in interest, So how much money in principal did I put into account A? Do you know? No. So what do you call it? Generally, for us, usually X. Now, unlike chapter 1 where we fiddled around with account B to come up with it, you don't have to here. How much money did I put into account B? Take a guess. It's not X, so therefore it's Y. So you can put Y here. What?
I thought she sneezed.
Alright. And the total for all my accounts is
1,500.
1,500. So what equation can I set up with this x, y, and 1,500?
X plus Y.
X plus y must equal 1,500. How much I put in the first account plus how much I put in the second account
Man,
has to equal 1,500. Alright, how much interest did my first account earn?
9.25.
But how do you find that out?
Which is 0.0.
Well, it's going to be 0.0925.
You said, but how do I find it out?
How much money did that generate?
You don't have time to about 1,500.
That would be if I threw all the money into that first account.
Owing to the interest of 228.75.
The formula is I equals PRT. What's T equal to
Times.
here?
Total.
1, so the T is irrelevant. So you get principal times rate. What's the principal of the first account?
X.
What's the rate?
9.25.
9.25.
I meant 0.0.
Well, the rate is 9.25%. So what do I do with 9.25% and X?
9.25X.
0.0925 times
Same thing with us, 1675. Y.
0.1675y.
Multiply, still plus in the middle.
And what has to be added together? The interest from the first account plus the interest from the second account plus equal
228.75.
228.75.
I can tell you, but don't ask me when I don't do no more.
Ah, but
It's
I want you
sad.
to.
It's sad.
So, there's our equations. And you have a choice. I don't care which way you solve it. You can do substitution, you could do elimination. But I'll tell you, I personally like, in this case, substitution. Because the first equation is really easy to solve for either variable. And when you plug it into the second equation, it looks like the equations you started off with in chapter 1. If you do elimination, it gets a little trickier because you'd have to multiply the top equation by negative 0.0925, and therefore you'd have to also multiply 1,500 by negative 0.0925. So the numbers get a little ugly, but it's doable. So I'll let you solve that
No,
now.
I go to the rest of it.
Good. All right, so let's see.
So is
see,
Andrew right or not?
Solve for x or y in the first equation.
So is Andrew right?
Y, I don't know.
Y equals 15.
I don't have the answers. Y equals 1,500 minus x. Plug that into him. So you get 0.0925x plus 0.1675 times 1,500 minus x equals 228.75. Alright, so this becomes 0.0925x plus, what's 16.75% of 1,500? In other words, what's this times this?
251.25.
251.25 minus 0.1675x is equal to 228.75. Alright, add the like terms together. Move the number to the other side. So what's 0.0925 minus 0.1675?
Negative 0.7.
Negative point,
Why do you have that arrow like that?
Hold on.
move the number to the other side. I don't like writing it twice.
0.75.
Huh?
I'm doing something wrong. Don't listen to me.
Say it again.
Negative 0.075.
Negative 0.075x is equal to 228 minus the 251. I hope it's negative.
Negative 22.5.
And then divide both sides by negative 0.075. You get x equals
300.
300. Where'd you screw up? You didn't look? Did you solve for y? If you solve for x, the answer will be a little bit different. Now, if this is x, how do you find y?
Plug it in.
Plug it in. Which one do you want to plug it into?
So,
The top one, much easier.
but of course.
So if x is 300, I can do this in my head. Y has to be
1,200.
1,200. So that is a word problem that you can do using a system of equations. I find it easier than the way we did in chapter 1 because people screw up 1,500 minus x or x minus 1,500. So I like this style of doing it better for mixture of accounts or any mixture problem.